So my name is Satish. I work for Siemens EDA. So today, thanks for coming. Thanks for coming for DAC and for attending all the great sessions from Siemens EDA. And for today here, we got a great panel, mainly focused on achieving industrial grade AI in EDA, right? And I got John Linford. He's head of product, EDA and CAE from NVIDIA. He's going to be the moderator. And I have all the key leaders from Siemens EDA across the entire portfolio of products, starting with Amit Gupta. He is a general manager for custom IC division. Ankur Gupta, he runs the digital creation platform. And Ajay Kovia on the GM for EBS, Electronics Board and Systems. And then we have Abhi Kolpekwa, he's a general manager for digital verification technology. And finally, Juan Ray, he is the general manager for Calibre. So we got the whole key leadership, the technical leadership of Siemens EDA here. And John, you can take it over.
All right, thank you very much. Yeah, welcome to the panel. Fantastic to see so many people here. So I wanted to kick this off with a question to essentially all of our panelists here to sort of set the stage and get us started. But AI's capabilities can be truly dazzling. If you've ever interacted with a chatbot, a ChatGPT, it feels like magic at times. And so given the apparent capabilities of this technology, why do you feel we need EDA-specific AI agents? Why do we need sophisticated industrial-grade AI that's specific to EDA when we have these generic general-purpose chatbots that are obviously so capable?
Yeah, sure. I can get started. So a little bit of background about me. I started a company called Solido Design Automation back in 2005, and we were focused on applying AI to the custom IC space. So how can you, for example, do Six Sigma verification of your design, which would take 5 or 6 billion simulations brute force? How can you reduce that down to a couple thousand simulations? And in that journey, we didn't know this immediately. It took a few years to figure this out, but there's a real difference when you're applying AI to EDA applications compared to consumer AI or the general AI that you see. Customers care about things like brute force accuracy. They need to be able to sign off on the results and be able to trust the results. They need verifiability to be able to make sure that they could see the results converging and be able to go and defend the results in a design review and not have the results be black box where they're not sure how the results came about. You need the results to be, the AI to be general, right? So it can work across a number of different types of problems. So there's all these kind of attributes that apply to industrial grade AI that are different than consumer. That's really, really important, we found, when you're getting engineers, when you're getting design managers, directors, VPs of these organizations to adopt AI for chip design or for board design. So those are the types of properties that we started incorporating when we were designing our algorithms and our user interface and how people interact with the tools that we found was really important.
Yeah, and I can maybe add a quick data point to that. Just in terms of commercially available ChatGPT, to your point, versus what we find acceptable for our customers, let me walk you through an A/B test separated in time by about 6 months or so. So we started about 6 months ago looking at LLMs that are available, and at that point, just feeding all of our documentation to that model and getting responses back resulted in about a sub 30% accuracy rate. Kind of understandable, right? Because where are these commercially available models getting trained? Not on EDA data, not on RTL, not on Verilog, not on Calibre information, Tessent information, not that kind of data. And now fast forward to where we are now, that's at an acceptable 80% plus rate. So based on what Amit was saying, leveraging the sort of work that we've done here at Siemens EDA, that's the result.
Yeah, just to add a little bit more to that. So, I would say that chatbots are something that are important to have, and it's kind of a base functionality that we're all adding to our tools But there are also other opportunities for AI. So, for example, in the space that I manage, a lot of our tools are interactive. And so things like being able to use AI to predict commands is something that we built into the tools. And that's something that kind of goes beyond the chatbots. There's also other opportunities and where you need specific models, whether it's around performance or, as Ankur said, whether it's around the type of results you get from those models. You really do need specific models. And what we found is that if we take the time to train those models properly, then the results actually are quite good.
Yeah, and I'll echo everything that previous guys have said. That in the area of functional design and verification, the sophistication of what we require, it's very hard to expect from a generalized LLMs and generalized chatbots. Okay, we need a very tighter integration of our tools that can work with agents, and there is a lot of back and forth that actually happens there as well. So for us to be able to be very effective and provide that value to our customers in design verification kind of spaces, there are some niche areas. For example, we've identified like 5 different areas that we actually really need to zero in and actually create value to our customers. And if we just pick up something off the shelf, that value is going to be highly diluted. Okay, so so this is why we really believe that there is a lot of AI investment we have to do as EDA vendors to really come up with solutions that our customers find very useful and impactful. Okay.
Well, in the physical verification space, we are in the domain that it has the fundamental characteristic that you really need a black and white answer, and it has to be exact. So a lot of AI applications historically has focused in optimization problems that then they are not that easy to apply in general to the nature of physical verification. However, when you look at Calibre, for example, you have an infrastructure that is used both in physical verification, where you have that characteristic, as well as in the semiconductor manufacturing space. And there is where there are many optimization problems where AI can help, and indeed helps. For example, in model creation, a model that needs to represent how you print a polygon, a feature that it is in the layout, and it has to be calculated as close as it will get printed. We're talking about sub-nanometers models. And there is where we have excellent proof of applying these models and obtaining excellent results. And when looking at LLMs and looking into where to apply for multiple ways to improve productivity of teams, we see it as a whole process that we are moving in that direction, and we have introductions here at DAC that hopefully we can talk more.
No, that's excellent. So it's really clear that we need specialized industrial grade AI specific for EDA to really realize the potential in the space. So my next question here is really more for Ankur. So your products cover many areas of the digital design cycle. How are you seeing accelerated computing and AI actually affecting these workloads? Are we seeing users pick up these tools today, and how is it changing their day-to-day?
Yeah, absolutely. So let me just take a minute to mention what the digital design creation platform covers. We've got Test. Many of you are users of our Tessin product line. So this is DFT. We've got Aprisa. So this is RTL to GDS. We've got other products such as high-level synthesis products, Catapult. We've got Power RTL optimization, such as Power Pro. We've got EMIR products such as Empower for analog and digital both. So now back to your question. For decades now, at least 10 years plus, in the space of test failure and diagnosis, we have had ML AI capabilities running under the hood, primarily ML, unsupervised learning, because it's a big data problem. You can think about this. There are test failures. Now you've got to figure out which segment of a certain manufacturing defect how do I trace that, right? Or some cell or some geometry inside of a cell. So it's a big data problem. So that's been around. There are capabilities in the RTL to GDS space. A year ago at DAC, we were talking about automated macro placement. There were papers from NVIDIA, there were papers from Google talking about reinforcement learning being used for automated macro placement, right? So that's kind of been there already. Then came the design exploration. If you look across other EDA companies, everybody's got a design exploration capability. Our product also has a design exploration capability. So that's kind of the current state. Automation of these flows and getting benefit. Now from here where we take off and how well we do in terms of improving power performance area, which is at the heart of every chip, in terms of generative AI to improve the knowledge of senior designers or train junior designers in 1 month instead of 3 months. These are the sort of things that are ahead of us.
Yeah, excellent. Does anyone else want to comment on this? No? Okay, then. So the digital verification space especially has seen significant implementation of machine learning, generative AI. How do we see AI being implemented across the Siemens EDA tools as of today?
So the digital verification space, as I said, we've identified 5 areas. First one is a smart generation. This is where we're actually applying generative AIs to create different kinds of verification infrastructure, including design test benches and things like that. Then we have what we call it as smart regression. This is where the ability to handle your verification workload with optimal resource deployment. Okay, and then the third one is we call it as smart analysis. This is where finding insights in your verification data. We generate a whole bunch of data, and then applying analytical AI allows us to basically find really insightful sort of information that actually allows us to make some very informed decisions. Then we have smart engines. This is where we put AI inside the engine to be able to sort of make some very, very intelligent decisions. These decisions could be in terms of managing the scale, managing the performance, and so on and so forth. One of the really cool innovation that we are bringing to the market here is we are shifting the definition of simulation from how fast your simulator is to how effective your simulator is. So for example, if you have coverage goals of, let's say, just for the sake of it, 90%, and you're taking 20,000 test cases that you randomly throw at your design and watching the coverage needle to move, you will be happy for the first 60, 70%, but the last 20%, you're really going to basically spend a lot of compute resources and you may not see that coverage needle moving that much. So before you apply those test benches, can you apply the AI algorithm and use predictive analysis to predict the effectiveness of that test bench? And if the answer is no, don't bother running those test benches. Now we have basically shifted from how fast your simulator is to how many test benches do you really need to apply to get the coverage that you need. And that mindset is changing because of AI. And the last one is debug. We have smart debug techniques now where we are really applying the analytical AIs to basically get you from the signature of failures to the exact root cause of a failure. 40% of the verification workforce today in the world, guys, is being spent on debugging problems to find out the root cause of why something is happening, which is basically erroneous in nature. And our Debug IQ solution is allowing people to take those cluster of failures from your regression forms to 1 or 2 design commits that has actually happened in the world across your global teams and zero it down from basically weeks and weeks to few hours. And that's the productivity shift. So to answer your question, what's happening in a digital verification is we are changing this whole notion of performance in the tools to the productivity of our end users. And that's what we're delivering through Questa One Smart Verification Solution.
So I think the point that Abhi made about simulation is really important because there's a lot of other simulation areas where we run thousands and thousands of simulations. And so this ability to reduce the number of simulations you have to run because of some AI agent or some AI that can help is really very, very powerful. The other aspect of simulation too is that it generates an enormous amount of data. And so being able to apply AI techniques to limit the amount of data that you have as an engineer have to look at to figure out whether or not what the solution space is or what the right answer is also tremendously helpful. And I think you're going to see more and more of that as we start applying these AI techniques to our simulation environments.
And one important thing I want to add here is, the definition of productivity. Productivity is a very open-ended term, and what we believe is, productivity gets reflected as faster engines. This is where you're actually sort of accelerating your tools and creating them more scalable. And then faster engineers, where you're actually working on the efficiency of the engineers by applying on AI. And then fewer workload. This is where you're optimizing the cost by basically eliminating and optimizing the cost, the tasks that are required to get the job done.
Yeah, and just to add to that, so I'm in the analog custom IC space. So I run the custom IC design and verification platform, and philosophically, it's very much aligned with what you were just saying, where we talk about how the cheapest simulation is the one that you don't have to run, right? So for the first order is, can I reduce the number of simulations rather than brute forcing it and using machine learning, reinforcement learning type techniques to do that? The second is, okay, well, if I have to run the simulation, can I speed up that simulation? So can I go into the solver and embed ML/RL to be able to reduce the simulation time itself? And then you're going to get a multiplicative improvement by reducing the number of simulations. And then if each simulation itself is faster, then you get that productivity improvement. And then on top of that, now with generative and agentic AI, we made an announcement this morning that we've launched the new Siemens EDA AI generative and agentic platform to enable those kinds of capabilities, which again is compounding the value to the customers for reducing the number of simulations and reducing the runtime of a simulation, where now through natural language, designers can go and interact with the tool. So you can have junior designers come up to speed much more quickly, do setups, do results generation, write measurements with natural language. So along each of those buckets, you're getting a multiplicative benefit for productivity, and I think a tremendous amount of value. And by the way, that Siemens EDA AI system applies across our whole portfolio. So across all these areas, we have one common system to power the generative and agentic AI capabilities in our tools.
I guess that I would add only one point regarding the several phases that Amit was highlighting where to apply AI. I was mentioning that on the manufacturing side, for example, of Calibre, one of the key techniques that it is used is optical proximity correction that consists in generating an image with the layout that has been created, comparing the difference of that image with the layout, then adding corrections to the layout, generating the image again, and iterating to convergency. In that whole process, these techniques are key to actually reduce the number of iterations, because all this is extremely computationally intensive and expensive. So any iteration that can be reduced by applying these techniques is a major win.
Yeah, that's excellent. So given that this AI platform permeates the entire portfolio, it goes across everything, how do you approach users who want to fine-tune the AI or further train it or incorporate their own data or their own AI into your platform? Is that supported? Can they do that?
Yeah, absolutely. The whole philosophy that we have for the Siemens EDA AI system is to be open. So, open from the perspective of the models, the LLM models that you want to use. So use the LLM models that we're shipping, or bring your own LLM models with the ones that you trust. We use a RAG-based approach, so you can easily take advantage of the data without having to, keep fine-tuning your models all the time as the models improve. But if you want to fine-tune the models, that's also something that you can do with the Siemens EDA AI system. Be able to interact with third-party tools, be able to bring in your own Jira data, Confluence data. So have this entirely open system. And the reason why we see that this is important is we hear that customers don't want 20 different AI systems, one for the Jira, one for this tool, one for this other tool, one for this other tool. Have one hub of a Siemens EDA AI system that can bring in all the data, bring in all the tools, and connect it all together to be able to ultimately improve the productivity for chip and board design.
Yeah, I would say when we talk to customers, they always ask two questions. One is, can I use my own LLM? And second is can I train the model using my data, but not share it with anybody else? And so I think any system that doesn't support those two things is not going to go very far. And that's why it was one of the fundamental things when we decided to build this environment. Those were kind of fundamental things that we said had to be supported.
Yeah, I'm glad you raised the point about training on your own data and not sharing it with anyone. So after our joint talk earlier, someone found me on the showroom floor and asked that specifically, that how do I know if I'm training an AI on my unique design data? How do I know that doesn't go anywhere? How does Siemens AI platform approach that?
Yeah, I mean, absolutely. So having an on-premise deployment, right? That's not connected to the internet and taking data out, but sitting within the customer's secure data center. And that could also be a cloud, but within the customer's secure cloud as well, or on-premise. So putting it within all the IT infrastructure that the customer has and making sure it's secure there. Another interesting point about security is we hear from users that, okay, well, there's also different data privileges, but in a company. So certain users have access to certain data, other users have access to other data, and you don't want to contaminate, by having answers go from one source of data to another to a user who doesn't have access to that. So having a Siemens EDA AI system be able to honor the data access control privileges is really important, and that's something that we've built into the system that we announced today.
And just to add another point, so it's having conversation with a customer, and many of the top tier semiconductor customers, they still do their own EDA. Bits and pieces. They buy our commercial solutions, but when they have an idea, they don't just file a ticket and ask us to build it, right? They do their own EDA. And in this scenario, the one that Amit just explained, that's extremely useful, because now our AI system is learning their own development in addition to the commercial tools. So openness and then building up the knowledge is very powerful.
So shifting gears a little bit to look forward, what this enables for us in the next 5-10 years, for instance. Let's say, for instance, PCB design. So AJ, where do you see AI taking us in that area?
So if you look at kind of the systems design space, a lot of the work around AI currently is looking at how do I make a faster router? And that's an important problem to solve, and it's something that we're all working on. But I think the opportunities go well beyond that. When we look at the possibilities around AI, we look at three different things. We look at how can we increase engineers' productivity, because we all know that there's a massive shortage of engineers that is coming down the line. And so making our existing engineers much more productive is something that is critical. How do we get new engineers that are either new into the industry or early in their career? How do we get them to be productive to the point where they can take the full power of the tool? And then last but not least, how do we make sure that our users are taking full advantage of all the capabilities we have. And so there's a gamut of things that can be done in that space. One of the spaces, for example, is around model development, right? So everybody struggles with developing models for the various, whether they be the simulation tools or whether they be the physical implementation tools. So I think what you're going to see in the next 2 to 3 years is a lot of agentic type applications around things like model development, also things around how to solve problems that are repetitive and error prone, like wiring up particular bus structures in a schematic. That's something that certainly an AI agent could do. And so that's something that we see coming down the road in the next couple of years. Things of that nature where it's eliminating repetitive, error-prone tasks that engineers don't necessarily have to be experts at, where we want to be able to make sure that they can take full advantage of the system. And then last but not least, I think you're going to see a lot of work around simulation, because that, again, as we continue to build out our digital twins, we're starting to see more and more simulations being used in designs. And so there's a lot of work that's going to be done around improving simulations, making sure that, like I said earlier, as we generate more and more data, to be able to visualize that data better to help the engineer decide what the right answer is when they're doing solution space analysis, and also to cutting down on the number of simulation runs.
So maybe I can make some comments regarding where we are seeing the most immediate introduction, even in the physical verification space, because this thought got triggered by some of the comments before. Specifically on the area of increasing productivity of the engineering teams. There is where we just introduced a new Caliber Vision AI implementation, that it is focusing in shortening the gap of understanding a very large volume of errors. Typically, when you do physical verification for every block, you end up with clean IP blocks, but when you're composing a very large SoC, you end up getting billions of errors. And we're talking about thousands of verification operations that are being run. So the focus there is to generate clusters of tasks that are creating the errors. So the first thing that happened then is that you have a compression of the number of things that you need to see, because you end up instead of having to verify each one of the rules, you end up verifying a smaller number of clusters of rules that we call signals. Now, it is not just that. Those signals then are not compacting the information that you need to interpret, but in addition to that, clustering the total number of billions of errors into smaller groups that you can go and fix. So there is an example of increasing productivity specifically for getting things applied earlier on in the design stages, as opposed to later on, and in addition to that, interpreting the data faster. Yeah.
I love the point about automating simple, repeatable tasks, because of course we like to give AI these grand challenge problems and see how far it'll take us, but it's easy to overlook the real benefit that comes from accelerating the engineer with the simple and the repeatable, and simply letting the AI do the simple job and let the human focus on the difficult job. That's a great strategy.
Yeah, I think there's, I hate to call it low-hanging fruit, but there are opportunities out there that can be solved very, very quickly. Just to give one example, we just introduced something called Smart Data Sheets, where it allows you to use generative AI to help build models by scanning through PDF data sheets and pulling the data out that you need. That's a very cumbersome, error-prone type of operation that can very easily be done by AI.
And there's an element of what do you want the engineer to focus on? So if you can automate some of these tasks, which we have, and give an Aprisa example, we're introducing AI agents for custom clock tree generation. Okay, so now what happens today is people have to go through click, 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 set up a form, this, that, get an H tree or get a certain type of clock tree. Fine. You put in all this effort, you get the result. Now, if an AI agent comes in and gets you that result with a natural language interface, then that same day's worth of work for that engineer now shifts to, okay, that didn't work, this didn't work, now I'm going to go try this other clock architecture, right? More interesting work. And in a panel that we were in the morning, a customer was commenting that AI is not just a top-down decision within each company, it's also bottom-up. Every engineer wants access to this kind of technology. So it's, to your point, it's a drug for engineers because you're simplifying their lives, right? So why not?
Yeah, I think one of the things I really believe we are moving towards, and I repeatedly say this, is basically when we take this mundane task away and the manual tasks away from the engineers and make them more efficient, I think we will force the engineers to be more creative. They essentially have to think more about problems than how to use the tools to solve the problems. If we as EDA vendors in Siemens EDA, if we are successful, we're essentially going to take the manual part of that task away from you, right? And then one of the things that I can quote here is like system Verilog is a standardized language for verification today, and it takes a lot of time and effort for people to learn this new language. How about a generative AI comes and actually creates those system Verilog assertions for you automatically, and then your task as a verification engineer is to really see if it is basically covering the verification space that you really want your tools to do. And that is really converting your task from learning a system Verilog language, writing those manual assertions that takes a significant amount of time for a new grad or new people in the industry, to really validating if thinking about the verification scope, verification coverage. So that really means an upgrade to our verification engineers enabled by AI.
Yeah, so Juan, you gave us some great examples of AI used in physical verification. How about digital verification? What's coming in the next 1 to 2 years?
Well, I really think that digital verification is, if you just look at DAC right now, there's so much of digital verification talk going on here. I think it's a very fertile space for applying AI, and I really believe that verification will force, or AI will force verification to basically tie in the design intent to design creation, to the functional sign-off, to the structural sign-off. I really believe that people will shift from, am I just going to verify point A, B, C using specific tools, to can I actually take an entire agentic AI-based approach that takes from design intent to an RTL sign-off before we get into the physical implementation of a chip. Okay, so I really believe that the next 2 to 3 years will be very exciting in the design and verification space by application of agents that take your design intent and design spec and map it onto a high confidence RTL, so to say.
Yeah, that's excellent. So what would you say is the next grand challenge for AI? Where are we going in the generation of AI itself, and what challenges will we have to overcome to create the next wave of AI accelerated EDA solutions?
I can take a stab at it. So anytime we talk about grand challenges, we start with customer problems. Now, in my space, the digital design creation platform, from what we hear, it's the long pole in the tent. It used to be functional verification. I think there's been a lot of progress. So now digital design creation is the long pole in the tent, meaning that if you want to design a chip faster than the 12 to 18 months that it takes today, you've got to leverage something like AI to shrink that substantially. And that is while maintaining the power performance area, with the ability to burst compute, right, with acceleration of compute. So looking at all of that, We think the customer problem is, the set of customer problems is telling us that we've got to continue to deliver PPA. We've got to continue to deliver productivity benefits, but now with AI, it's no longer percentage, it's X factor productivity benefit. So we just announced Aprisa AI this morning, and with a target of 10x productivity benefit. And then the third piece is, where does the work still gets done on compute. So you've got to also have a compute efficiency, because there's a sustainability component also attached to AI, right? We can't just have a whole lot of workloads running on data centers. So we have to have, so in Aprisa AI, we gave ourselves a challenge of 3x compute time efficiency. So that's core hour efficiency. That's a grand challenge, right? Productivity, PPA, plus compute efficiency in our space.
I guess I'll make a comment towards the future. I would say that there is a problem that ties also to what data is available where. And so this is not intrinsically an issue with AI, but I believe that one of the areas where it is important to make progress is in areas where you need to get truly to an optimal result. For example, writing a complex SVRF deck to verify a complete system. When you look at the way that these type of things get developed, they get progressively developed with smaller amounts of IP going all the way to full chips. And usually things need to be ready before the full chips are ready. So you have this problem of interdependencies and the data not being everywhere at the same place. So there is a need to actually progress in that direction, but there is a challenge, and the challenge is data access. And I can think of several other examples, for example, in smart manufacturing, where getting information from the design into the semiconductor manufacturing floor has proven benefits. But you have all these barriers that prevent that information to flow into that direction. And this idea in particular is an idea that especially academics started exploring 10, 15 years ago. And there have been this major roadblock that prevented more progress. And it also applies to the ideal utilization of AI to really accomplish the final goal. Yeah.
Yeah, I would say if I kind of look at it maybe a little bit differently, I think we've gotten pretty good about solving kind of these discrete problems. And so we can apply AI to discrete parts of the flow, if you will. I think the next challenge is going to be is how do we start putting those together? And so we can have complete workflows or sub-workflows to be able to do larger chunks of the processes using AI from start to finish. And it's going to take a lot more development to get there, but I think that's kind of the next challenge that we have in front of us.
Yeah, and I think just to echo that, I think historically we've thought of our tools, even in the custom IC space, as kind of discrete solutions. But even at this conference, we're talking to customers about how can we build out workflows between those tools, given the immense amount of data that's getting generated and being processed by the individual tools. Why not be able to take advantage of that information for other tools? And so I think there's opportunity even within our own spaces to do better kind of AI-driven value creation for our customers, and then between our divisions as well, there's lots of opportunity.
Yeah, Juan, you mentioned data briefly, but do you see data availability being a key challenge, and how are you planning to address that?
Yes and no, in the sense that typically to develop the tools, there is enough data to actually accomplish that goal. However, when looking at the practicalities of solving some key issues and making big jumps, there the data tends to be proprietary, and there is where we believe that this EDAI, Siemens EDAI infrastructure that Amit is leading and developing that can be deployed at the customer side and access the data of the customer with absolutely no need to share anything outside is going to be critical because it could help on creating tools that are flexible enough that use that data and produce the results in-house. Yeah.
All right, well, thank you very much. So we have about 15 minutes left in our panel. I'd like to invite the audience to come to the microphones and see if you have any questions for our panelists. We're happy to open the floor and have a conversation. So don't all rush up at once, but questions from the audience, anyone?
One of the issues that new graduates are facing in software is that a lot of the early jobs that they can gain experience with is being taken by AI. Where do you see in the EDA industry fresh graduates fitting? Because they need to build their experience. And a lot of the elementary jobs are going to be, if taken by AI, how do they build their experience?
I can take that. I can tell you the philosophy that I'm adopting in my division today is, EDA in particular has a very interesting story, right? We have a bunch of computer scientists trying to create solutions or softwares that are used by the hardware engineers. And if you look at the hardware engineers and software engineers, they're born and brought up differently. Now we throw in this new animal called data scientist in the picture. Okay, in my division, for us to develop these AI solutions, we got to basically find a way to get these software engineers and data scientists to work very closely together. So we are hiring software engineers, we're hiring data scientists too. And it's very interesting and important for us to basically get these guys to communicate with each other. The skill that I personally really value a lot is, do we have some engineers who understand how the software is developed while accelerating that development by application of data science or statistics kind of a background? So, my guidance or my advice to the new graduates is, we got to have AI awareness, at a minimal while having the software development skills. They will coexist, in my opinion.
And just a bit of a different angle is I see AI as like an opportunity, as a superpower for new grads or junior engineers, because now they're armed with this co-pilot where you can ask questions in natural language and be able to interact with the tools, and you don't have to go through that really high barrier to entry that exists with a lot of tools. So I see it as kind of really reducing the barrier to entry for a whole host of new engineers to come into chip design.
Yeah, I would definitely agree with that. I think one of the biggest challenges we have with new engineers is building that domain knowledge. And any way we could use AI to help build that domain knowledge faster is actually gonna help new engineers.
Yeah, actually, I have some comment. The first thing is that if we are looking at the current situation and the next several years, there is a tremendous need for people that come trained with EDA training. As a matter of fact, something that we have been doing for many years is train engineers on EDA, because there has been this major decrease of the number of professors that have been training EDA, their grads in EDA. So I see that basic knowledge is fundamental and needs to be there and so on. So in the immediate future, there is no worry. And then I completely echo what it was mentioned here, that we need to look at AI as a way to help with the more common tasks, to accelerate the training of junior engineers to be able to produce much more intelligent results or much more advanced results when they do not have the years of experience that senior people have. That is on the usage of the EDA tools. So, yeah, so those.
I'll add a non-EDA perspective. This is anecdotal. So I was talking to a customer. Customer says they're using Cursor pretty extensively. This is like an open, it's available for code generation, right? So a new college grad that they hired spend their time writing prompts rather than writing software. And the result of that is pretty amazing because the prompt was long, like 8 pages long. And the software that was generated simulated first time. So an example of trained in CS, understands algorithms, understands how to write prompts, understands where to use C++ code, where to use Python or whatever different elements, and is able to write a prompt which then fed to an AI engine is, to your point, that job of actually writing the code and generating the final result, that is, in this scenario, that job is gone because now AI is handling it. But that same junior engineer is now evolving into writing prompts that can accelerate tremendously the net outcome that they were seeking in any case.
And I can actually add an anecdote to that. I was at a meeting once where someone asked the NVIDIA CEO, Jensen Huang, effectively the same question. And his answer was, AI is not taking your job. The engineer that uses AI is taking your job.
Yeah, hi. Can you hear me?
Yeah, we can hear you. Yeah.
Okay, thanks. So it goes back to the question on the data security, right? Thanks for asking. My question was, so we have this model and we are going to use it or deploy it on the customer side and use that model on our own data set, right? And the model is going to get trained or learn from it or whatever using the customer's data sets. Now, as we have to upgrade the model maybe, right? You are the EDA industry, so we go through upgrades, patches, whatever, feature enhancements, whatever. So how does that come back? We can do it on the customer side, that you said, with our own security and our own group permissions or whatever. But how do you handle upgrades is what I want to know, so that that data that the model has already learned from customer's database is not going back to the upgrade cycle.
Yeah. So as the model is learning on the customer data, that model itself is never leaving your premise. So that stays there. But now you're wondering, okay, now I want to upgrade the large language model. Or
whatever features you roll in, right? For your whole, say, the system deployment that you have.
Oh, okay, yeah.
Right now,
So
right?
think of it as think like the model itself that's been training and learning in your environment. That's a separate piece. So it's not like, we upgrade the Siemens EDA AI system and then you have to change the model. You can keep that same model that's been trained and learning over whatever period of time and use that with the new system, with the new features. So it's very much adaptable and can plug in your existing model that's learning into this new and improved Siemens EDA AI system.
Yeah, so our software solutions are basically LLM agnostic. So, this is what the openness that Amit and even AJ basically alluded to. So we are offering AI solutions that actually are LLM agnostic that allow you to pick and choose your own LLM. So if you have been training your LLM by yourself, right? So, and then we basically roll out a next version of our software, we're going to be plugging into your LLM, which never left your premise to begin with.
Okay, then if we were to use our own LLM, then how would we upgrade that LLM without compromising on losing our data then?
Yeah, so if you're using your own LLM and you want to go ahead and upgrade it, then that's a separate piece. So you can upgrade your LLM with whatever cycle it is that you want to upgrade it, and then that can keep getting plugged into the Siemens EDA AI system that's independent of that and getting upgraded as well.
Okay, cool. Good to know that. Thank you.
Yeah, for sure.
Hi, can you hear me? Yeah. Do you think this Gen AI will reshape the analog design flows, or will it impact just the digital and the verification side?
Yeah, absolutely. It is reshaping and will be reshaping the analog flows. So and one of the points that I always like to make is there's tremendous opportunity still in advancing machine learning, reinforcement learning, those traditional AI algorithms, and we're constantly finding new areas to apply traditional ML RL techniques and new ML RL techniques that we're inventing to solve problems that those algorithms are conducive to solve. But in addition to that, we see a lot of opportunity for generative and agentic AI to really improve the workflows for designers, improve the usability of the tools, improve the speed at which problems are getting solved. So one of the examples that we have in our demos, and I don't know if you had a chance to see our demos outside, but you can interact in natural language saying, I want to do this kind of setup, and I want to sweep the temperature from this to this, and I want to use these process corners. Just in natural language, it's automatically doing tool setup, and then the tool is running, and then there's an error that comes up. Okay, well, just in natural language, hey, I saw an error come up. Can you help me debug it? Okay, well, the Siemens EDA AI system goes and pulls that error log file, gives guidance to the user, and then you can go in and fix it even with using the Siemens EDA AI system. So completely changing the interaction methodology for the engineer with the tools and adding tremendous amount of productivity. You can do things literally in minutes that was, you're clicking around. So I think the user experience paradigm is completely changing, which, as I was saying earlier, is compounding on all the value that we're doing on ML and RL, which is also increasing as well. So I think tons of opportunity, and happy to give you a demo as well of the things that we're doing in the custom IC side.
All right. Yeah. Thank you. Thanks so much.
All right, I think we have time for one more question if anyone's interested.
Yeah, so nowadays with the AI, people are able to do more complex stuff and EDA. How about my question is around let's say if LLM makes a mistake and the user is using LLM because they don't know how to use the tools. So what are the debug capabilities you have, or what are your thoughts on how someone can debug that they don't understand and LLM made some mistake within the flow in very complex flow?
Well, there are various shapes and forms of where LLM is actually going to mess up and how we catch it. I'll give you a simplest example here is we have a tool called Property Assist. Okay, it takes your natural language or even your design spec and converts that into a system log assertion or a property. Okay, now how can you be confident that it's a high quality property, right? We have now the ability to immediately run a formal verifier at the back. That is the first thing that you get is okay, as soon as you write the property, you're guaranteed that it's a standard system log assertion that can be evaluated by a formal engine. Then you can actually, we have another generative AI solution that creates a test plan from a same design spec that you created. Now you have a test plan, you have an assertion, you made sure that the assertion is verifiable, and then you have the ability to connect that assertion to the specific bullet point in your test plan. Now you see that spec that you had, the LLM that converted into a test plan and an assertion, you have the ability to do the cross-referencing as well. So there is, this is a specific example I'm taking, but there are many such examples that we can create. The other things is, and I've been asked this question to many of my customers, an interesting one is putting one LLM against another, right? So you basically query it, put multiple LLMs against each other, and then come up with a way to basically say, is there a consistency or is there a very wide range of response that triggers this? And people are actually building agents on the top of this at this point to connect, or compare the broad spectrum of the responses that you get. This is obviously evolving at this point, but there are hooks that people are already thinking and evolving with at this point.
Thank you.
And just one other example there is giving you access to the sources, right? So the LLM produce some sort of response, give the source as well so that you can go in and see the actual source. So it's part of what we're doing as well.
Does Siemens use any generative AI to create your software products? Is all your software handwritten by people, or is it not handwritten by people?
It's written all by AI now. Yeah.
Really?
That's
Cool.
You're just kidding.
Just kidding. Yeah, just for the record. Yeah.
No.
No, the answer is, no, we don't use, entirely AI-based software generation. Okay.
Yeah, there are very strict policies regarding where AI can be used and where it cannot be used that were established by the parent company, Siemens AG, that consider absolutely every aspect of legal issues that we all need to be concerned, like, for example, copyright protection, given that you don't know where those LLM models or those generating code engines are coming from or how they have been trained. So there are very, very strict policies regarding where it can be used and where it cannot be used.
Yeah, we could easily have an hour discussion on a panel like this around AI-generated code.
So unfortunately, since we don't have an hour left, I would like to close the panel by inviting each of the panelists to give us maybe 15 to 20 seconds of closing thoughts. If you want to just say something to wrap up the arguments here, rapid fire closing thoughts, starting with Amit.
Yeah, no, I think we're doing a lot of exciting things with AI on the custom IC front, from MLRL, generative agentic AI, and I think we're delivering to our customers real use cases with real value, and excited to collaborate with our customers as well. So if there's ideas that you have or suggestions that you have, we have a broad portfolio, broad toolkit of IP assets that we can bring to the problem and help solve it for you. So yeah, looking forward to it.
Yeah, in the digital design creation space, we have some market-leading products that use ML, like Tessent. So if you are a Tessent user, I hope you are. Please go ahead and try those capabilities. If you are an aspiring Aprisa user, I hope you are, then try that also. Look up our Aprisa AI launch that we just released this morning. And then there is a lot more opportunity on the power front. Energy efficiency is extremely important. There is research going on to enable Power Pro and Power, these types of products to deliver outsized benefits from a power front. So stay tuned. We are putting in a lot of energy into this space.
Yeah, just to echo what Ankur said, I think if you take a look at our products, there's actually quite a bit of AI embedded in those products already. And I think you're going to be surprised to see how much AI capabilities we're going to be adding in the very near future. But, really for us, there are a tremendous number of opportunities out there. And really what we look forward to is collaborating with you, our customers, to try to prioritize which of those opportunities we want to focus on first, because there's, I think one of the things that, we definitely talked about today is how many different things we could possibly focus on and how many opportunities there are out there. And so where we need some help is to help prioritize and focus on really those key issues that you guys are facing. So that's where we can put our energy.
Well, mid last month, we actually launched Questa One smart verification solution powered by AI. And this is a fundamental shift that we are actually trying to make in the design and verification space, where we're basically saying that the isolated tool performance is not enough. We need to have the ability to connect different tools and apply AI to basically deliver end user productivity with faster engines, faster engineers, and fewer workloads. The cool thing about Questa One is this is a collaborative effort that we basically kicked off with a lot of customers across the world. And when we rolled out the product, Microsoft, ARM, Rambus, MediaTek, they all came out in the open talking about the value of Questa One smart verification solution that we were able to deliver. We would love to partner with you guys, and more to come in the near future. But we are standing at a very interesting era where the shift from performance to productivity is becoming very natural and very rapid. And design and verification space is going to humongously benefit from that.
Yes, and I made the case in the beginning that in verification, in physical verification, you need an exact answer, then it's more difficult to actually find outstanding opportunities for AI applications, and more in the manufacturing side. On the other side, we have been applying many AI techniques for more than 10 years, and they are in production and they are proving outstanding results. Then I mentioned about how we are looking into the potential of AI to help with the productivity of results with this new introduction that helps you interpret data that it is in billions of errors and can be reduced to clusters of hundreds that help you improve the productivity. There are many more examples like that. We are working on, for example, best setup of the tools on a complex large cluster. Think that this runs requires hundreds to thousands of CPUs on a cloud environment, and then you have many options regarding how to set up things in the best way. Similarly, we are looking into how to do predictive, a predictive understanding of what the results are going to be. All that is happening, but we see this application of AI for productivity of the day-to-day work as one of the key venues of progress for us. Yeah.
Excellent. Well, thank you everyone for participating in our panel. I want to thank the panelists for these excellent comments. And yes, we're done. Please enjoy DAC.
Yeah, thank you, John.